episode 41, and let's just go. So, I realized yesterday that this here doesn't actually make it so that I don't get, um, doesn't actually make it so that the ball doesn't go up. Doesn't go like directly up or down. Yeah, like that. Because 1 actually makes it go up. Actually makes it go directly up or down. So this is not true. What I actually need to do is make the I actually need to make the y value, the starting y value, a percentage of the starting x value because since it's normalized, um, yeah, since it's normalized, if the x is smaller than the y, then the y becomes very large. So that's why it was continuing to go up and down. So what I need to do is make a new variable here. You know, it doesn't matter. It doesn't matter. So I just take this, I plug it in, then I do starting x, then I do starting x divided by 2. Like, here's the thing. I don't know if division or multiplication is better computationally, like resource-wise. Whatever. It doesn't matter. I could do 2 divided by 2. So if this is, I mean, okay. So if this is 1, this is going to be 0.5, and then it will be, it'll be, so I'm thinking of the unit circle thing that I learned from Sebastian Legue, you know, where there's a unit circle and then uh like the normalized vector um, is always on the unit circle. So if whoops, no, that's not right. This is 1 comma 0. So if x is 1, then y has to be 0, but if it's normalized, then obviously that's not going to happen. So right here, if x is 1, then y is going to be 0.5, which would make it so that it would go like this. It would, yeah, it would make it so that x is the largest value while y stays, like the value still has to stay on the unit circle. So it would go like this. It would go like somewhere here. And it would be like 0.6 something and like 0.3 or whatever the fudge it is. You get it. So that's what it's gonna do. Maybe I should do it more than that. Yeah, you know, I'm just gonna do some tests here. What? Why does it, what? Why is it carrying between sessions? Oh, do I actually have to? Do I actually have to do a setter here? That's fine, sure. And then I want this to be a float, and then I can, oh, actually, yeah, float. And whenever it's called, yep. So whenever it's called, I can do this here. Actually, is this correct? So let's see if it changes. Yep, nice. Perfect. And I have the directions here. Yeah. Okay, I think I fixed that. I think I fixed that, so that's fine. So whenever it's called, it just makes a new random number here, I think. Okay, now how did that happen? Now why did that happen? Um, under what, yeah, under what circumstance would y be larger than x? Nothing. There's no circumstance. So why did it do that? Why did it do that? Okay, you know what? I'm going to just print direction here. Hmm. What? Why is this positive? Why is y positive here? Oh, I see. I understand. Because negative 1, this was probably negative 1 here. Okay, and this changes every time. Okay, so this would be like negative 1. Let's just say negative 1. Okay. All right. Unit circle -1, right? -1. Actually, is that how it works? I thought it was also, I thought it was, what? Is there, oh, okay. Hmm. Wait, why is this negative? I actually don't know how the Godot. Okay, I actually don't know how the Godot vectors work. What the fuck? Godot vectors in radians? Wait a second. Oh, no, no. I do. I do. Never mind. Never mind. I'm trolling. I'm trolling. Didn't mean to do that. So, we got, yeah. So this would be 1, comma, 0. In Godot, this would be negative, or sorry, this would be 0, comma, -1. This would be 0, comma, 1. I'm pretty sure. I like have to go back. Yeah, I have to go back and just. Oh yeah, y positive y is down. Like why? Why? Why do that? Okay. Then it would be. Yep. Then this would be -1, 0. Nice. Okay, so. Oh, positive would be down. Would it? So from this, let's just guess what we can do from this. So this would be -0.87. So like, yeah. So like here, and then, bruh, and then 0.487 which would be, yeah, 0.487, which would be like here. So, yep, that's correct. That is as I anticipated. Okay, this one was almost completely left. So I just don't want, what in the world just happened? Yeah, I mean, supposedly some freaky stuff happens when you shake the screen here. Okay, now some freaky stuff is going on with my computer. Okay, why? I'm so confused. it's not happening anymore for some reason. Okay, this one was like down here. Okay, this one, I'm going to guess what the number is before I look. So this one was like here. So it's going to be high negative x and low positive y. Yep. No. Okay. Unfortunately, that's a problem as well. Like, if I move it, yeah. I mean, this is like somewhat of a functional game. Yeah, if I like move it into it, if I move the bar into the ball, then it bugs out, kind of. No. Yeah, okay. Fun. Okay, let's do... Okay, that would be high negative x, low positive y. My real question is, how is it... How is it negative and then positive? That's my real question. And how is the y greater than the x? Because, okay, because you can't have... Okay, let's say high negative x. And then half that would be like here. And then but it changes. How do you get positive y? How, like, what is causing it to get positive y? Like, if I do, okay, starting x, this is starting x. Half of this, so it would be like here somewhere. Half of this would be like here. Half of this for y would be like, yeah, like here. And how does it become positive? How does it become like this down here? All right, should go like that. But instead it went like this. Like, why? Why did it do that? Oh, and this is inclusive, actually. I mean, it's like close enough, I guess, right? Right. Yeah, it's like close enough. I guess it doesn't really matter. I'm just wondering how this actually how it gets a negative x and a positive y. That's what I'm wondering. This function may return incorrect values if the input vector length is near 0. What? Okay. Returns the result of scaling the vector to unit length, equivalent to v divided by v dot length. What? What? I don't get that. So you're telling me if there's a vector of like, okay, I don't want to do the math for this. You know what? Sure. Let's say this is, what is easy? What's an easy one? Um, let's say 2 and 3. That means this vector length would be oh, I see. Yeah, so that means this, okay, 2, 3, brr, that would be 4 plus 9, which is 13. Square root of 13 is like roughly, oh, fudge. Yeah, square root of 13 is somewhere in between 3 and 4, so this divided by something a little bit over 3 would be, yeah, it would be like a little bit under 1, be like point 0.9 or 8 or something. Yeah, point 0.8 or 9, something, something, something. This one would be like point, yeah, like point 0.6, something, something, something. Okay, so now how does that apply to what? Hmm. How does that make the negative x positive? How does that do that? How does that actually even do that? Is it because it's near zero? And it's just giving me some wacky stuff here? That might be it. That might actually be it. Um, you know, either way, it's pretty good. I don't think it's gonna give me. Okay, hold up. So this I don't get. I don't get this. I don't get why it did that. All right, either way, I think it's probably good enough. Okay, that is not good enough. That's not good enough. That's not good enough. Like, do I actually have to clamp this? Really? You know, I can also just do this, I guess. Sure. Oh, wait, actually. You know what? Hmm. 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 Yeah, I don't really get it. I don't really understand. Oh, that is so poggers. Whatever just happened there. That was so poggers. What was that? What even was that? Okay, I'm thinking whatever that was it got stuck in the wall somehow? I like what? Yeah, it gets stuck in the wall and then it keeps running. And it keeps running this here. Hmm. Yeah, I will figure out that edge case. I'll figure out the edge case later. That's fine. Okay, can you please? That's fine, I guess. So I guess the way to prevent it from being close to 0 is to just do 10, maybe? Like just to increase the number, like I could just increase it to like 100 or something. And then that would greatly reduce the chances of it being close to 0. Uh-huh, uh-huh. Yeah, I mean now it's working as intended, except this one. What? Except this one wasn't doing that for some reason. Hmm. Like, what caused this to... What caused X to be positive and Y to be negative? I might just make a post. That's fine. You know what? It works well enough for now. Well enough. So I'm just going to watch one of these videos and then I'm going to end the episode because I actually have things to do. So, yep, as you can see, I've already seen this one. This one is pretty good for me at some point. Bracky's recommended this one here. You know, I could probably just watch both of these.
Inheritance and composition are
I could probably just watch both of them, actually. That's fine.
two tactics used in programming to reuse your code as much as possible.
What? Composition. Sure.
Inheritance is very widespread, but I think there's a lot of times where composition would fit a little bit better. Let's say we have this setup. We have a player, and this player can attack, has health, and a hitbox. Alongside that, we can accept user input. And similarly, we have an enemy. This enemy can attack, has health, and also a hitbox, as well as some enemy-specific stuff like AI. In the world of inheritance, we would take the attack, health, and hitbox and drag them out to their own individual class. We'll just call this class entity, and the player and enemy will extend from this class. This moves all our code into one easy to change spot, so if we ever have to modify the code, it'll affect both the player and the enemy at the same time. We don't have to go digging through every class that has the ability to take damage. And if that were the end of the story, inheritance would be the perfect solution. I mean, right now, this is really easy to comprehend. But let's bring in another object.
Okay.
Let's say we have a tree. And similar to the player and enemy, the tree can take damage. So we can extend entity, but this causes a small problem. While we do have the health and the hitbox, now we also have the ability to attack, which we probably don't want from a tree. There's also a more potent underlying issue. Because we're using Godot, both the player and the enemy extend character body 2D, whereas the tree extends static body 2D. In the world of inheritance, at least in Godot, you can't extend from multiple classes, since player and enemy both need their own inheritance and character body 2D, whereas the tree extends static body 2D. In the world of inheritance, at least in Godot, you can't
Okay.
extend from multiple classes. Since player and enemy both need their own character body 2D code, entity must also extend character body 2D. However, since tree also extends from this entity class, that means it must also be a character body 2D. There's a few ways around this, and the most straightforward approach is to change tree from a static body to a character body. This isn't ideal though, because this gives the tree the ability to move. Alternatively, you could extract the entity class out into a static entity.
But you can... What? You can make a static body 2D move, I'm pretty sure.
And a character entity and decide
Okay.
which classes need to inherit from where. But as you can see, this is already getting a little bit complicated, and all we did was add a tree. There's got to be something better. Let's rewind a bit. Instead of using inheritance, we'll approach this with composition. Instead of making one superclass, you instead make multiple components. So for example, we would have an attack component, a health component, and of course a hitbox. Then the player and enemy would both just have their own list of components that they need. In this case, we have 3. Let's bring back in the tree from the earlier example. Because components don't care what class you're extending from, we can simply attach a health component and a hitbox component to the tree. And we're done. That's all the hierarchy we gotta worry with. You can see in this case, this is a lot more preferable to inheritance. And there may be a few odd things like telling the hit.
Why is my input doing feedback? Or why is my microphone doing feedback? What the fudge?
Hitbox component where your health component is.
I don't want it to be doing that. It's gonna sound horrible, actually, on the final video. Okay, I'll just mute myself while I watch this.
So it can send information about taking damage, but I think that's a valid trade-off. In Godot, each of these components would actually be a child of the player, enemy, or tree node, and you can arbitrarily attach them to any node that you feel needs these components. So for example, valid trade-off. In Godot, each of these components, and there may be a few odd things like telling the hitbox component where your health component is so it can send information about taking damage. But I think that's a valid trade-off. In Godot, each of these components would actually be a child of the player, enemy, or tree node, and you
Yeah, my microphone does this every once in a while. I don't know why.
can arbitrarily the component is so it can send information about taking damage, but I think that's a valid trade-off. In Godot, each of these components would actually be
It's still happening. Whatever.
a child of the player, enemy, or tree node, and you can arbitrarily attach them to any node that you feel needs these components. So for example, let's say we bring in a bullet. Well, for the bullet, we want an attack component, but we also want a hitbox component. It doesn't matter how much HP a bullet has. If it hits something, it's going to destroy itself, so we don't need a health. This is the basic idea behind composition. Let's go ahead and jump into Godot, and we'll build through a project where we use composition. All right, back on the project from last video.
Poggers, poggers.
I've gone ahead and removed any reference to the damage functions from before. I want to build back the damage functions from before, but using composition as a base. First off, I'll add a new node 2D to the enemy. Back on the project from last video, I've gone ahead and removed any reference to the damage functions from before. I want to build back the damage functions from before, but using composition as a base. First off, I'll add a new node 2D to the enemy and call it health component. I'll also add a new script to this. Starting off with the script, we'll add a new health variable, a max health, and inside of the ready function, I will set health to max health. Then I'll add a damage function and take in an attack from last video and subtract that damage from the health. Then if the health ever drops below 0, the parent will free itself. Back on the enemy, we'll add a new area 2D object and call it hitbox component. You may notice a warning about the shape, but we'll get back to that later. We'll attach a new script to it. We'll start by exporting a health component variable, then add a damage function, also passing in an attack like before, about the shape, but we'll get back to that later. We'll attach a new script to it. We'll start by exporting a health component on the enemy. We'll add a new area 2D object and call it hitbox component. You may notice a warning about the shape, but we'll get back to that later. We'll attach a new script to it. We'll start by exporting a health component variable, then add a damage function, also passing in an attack like before. So back on the enemy, we'll add a new area 2D object and call it hitbox component. You may notice a warning about the shape, but we'll get back to that later. We'll attach a new script to it. We'll start by exporting a health component variable, then add a damage function, also passing in an attack like before, and then we'll check if the health component exists. If it does, we will call .damage on it. And the health component variable can be set in the inspector, like so.
Damage. Damage. Okay, never mind. That's like an inside joke that I have with myself, I guess. Whatever.
One thing I don't really like about this is we can attach any node 2D to this health component variable. And for example, if I attach the sprite 2D, this would crash because sprite doesn't have a damage function. So instead, one thing we can do is inside of the health component, we can declare a class name health component. Then instead of just using any node 2D, we can specify that we want specifically a health component. Then inside of the inspector, we can see that it only highlights things that classify as health components. This is also nice because this gives us IntelliSense. So if I do control space inside of this function, we can see what it expects. Or if I control click damage, it will take us to the declaration. Let's go ahead and save these off to their own branches as health components. So it only highlights things that classify as health components. This is also nice because this gives us IntelliSense. So if I do control space inside of this function, we can see what it expects. Or if I control click damage, it will take us to the declaration. Let's go ahead and save these off to their own branches as health component scene and hitbox component scene. One thing you may run into is if you previously assigned click damage, it will take us to the declaration. Let's go ahead and save these off to their own branches as health component scene and hitbox component scene. One thing you may run into is if you previously assigned the health component and you go into the hitbox component scene, you'll see that it's already pointing towards a health component. You can leave this if you want, but it may cause issues in the future. So I usually just is if you previously assigned the health component and you go into the hitbox component scene, you'll see that it's already pointing towards a health component. You can leave this if you want, but it may cause issues in the future. So I usually just clear this and assign it for every enemy that I create. All right, let's talk about this warning now. So a hitbox needs a shape, and your first instinct might be to put it inside of the actual scene. And while that would work, this means that every enemy and every object that uses hitbox component would have the exact same hitbox shape. Instead, what we'll do, in the enemy scene, we'll actually attach a collision shape as a child of the hitbox component here. This allows us to use unique hitboxes for every single object. Inside of the scene, you can also set up collision through here, or you can do it in the enemy. So for example, an enemy and a player would want different collisions, so you can set it in their respective scenes. And the last thing I'll do is set up my web. You can also set up collision through here, or you can do it in the enemy. So for example, an enemy and a player would want different collisions, so you can set it in their respective scenes. And the last thing I'll do is set up my weapon to attack a hitbox. So for this, I'll check whenever we collide with an area, we'll check if it has the function damage, and if it does, we'll construct a new attack like before, and call the damage function passing in the attack. We can also do attack a hitbox. So for this,
Yeah, this is pretty dense. This is a pretty dense video. I'm not understanding all of it. Like densely, yeah, it has dense information. The video has dense information. Here. I will probably watch it repeatedly.
I'll check whenever we collide with an area, we'll check if it has the function damage, and if it does, we'll construct a new attack like before, and call the damage function passing in the attack. We can also do something neat with this code. If I head back to the hitbox component, we can also declare class name hitbox component here. Then inside of the weapon, instead of checking whether it has the method, we can see if it's a type of hitbox component. If it is, we'll pull it out into a variable and call .damage on that. This has the same benefits as before, where we can do control and space to see what the function wants, or we can control click it to see where the function is declared. And that's actually all we need to do for whether it has the method. We can see if it's a type of hitbox component. If it is, we'll pull it out into a variable and also declare class name hitbox component here. Then inside of the weapon, instead of checking whether it has the method, we can see if it's a type of hitbox component. If it is, we'll pull it out into a variable and call .damage on that. This has the same benefits as here. Then if I head back to the hitbox component, we can also declare class name hitbox component here. Then inside of the weapon, instead of checking whether it has the method, we can see if it's a type of hitbox component. If it is, we'll pull it out into a variable and call .damage on that. This has the same benefits as before, where we can do control and space to see what the function wants, or we can control click it to see where the function is declared. And that's actually all we need to do for composition. If I walked up to this cow, I can hit it. I'll also throw together the tree and the crate just to show you how easy it is once you've got these nodes set up. I'll start by dragging in a health component and then a hitbox. We need to do for composition. If I walked up to this cow, I can hit it. I'll also throw together the tree and the crate just to show you how easy it is once you've got these nodes set up. I'll start by dragging in a health component and then a hitbox component. And inside of the health component, I will set the health to 30. And inside of the hitbox, I will drag in the health component. Then of course, I'll add a shape to the hitbox, give it a capsule shape, and fit it to the tree. Then of course, for the crate, we can drag in a health component and a hitbox component. I'll attach the health component and set the HP to 20. Then I'll add a new collision shape of a rectangle, fit it to the tree. Then of course, for the crate, we can drag in a health component and a hitbox component. I'll attach the health component and set the HP to 20. Then I'll add a new collision shape of a rectangle. And just like that, if we go in the game, it takes 3 hits to kill a tree, 2 hits to kill a crate. Hopefully this shows you how powerful composition can be. Of course, it isn't one size fits all. Sometimes inheritance is better, sometimes composition is better. But of course, that's how everything is in game development. Hopefully this makes game development easier for at least someone out there. And as always, have a good one.
Okay. Sure.
Did you know that Godot has the ability
Okay, this was uploaded before this one. Nice. What the fuck? Okay.
to create custom classes? These are useful scripts that can hold variables and even functions, and can make your code more readable and extensible.
Okay. What is going on, bro? Please. Yeah, I'm probably going to listen back to this video and be like, wow, this sounds horrible. Hopefully the feedback loop is not... Hopefully it's gone now.
Leading to less bugs and more productivity. In this video, I'll be adding a feature.
It is not. It is not gone. Nice.
To a small project and show how classes can make this process easier, more streamlined, and less error prone. As always, use the timestamps in the description or chapters in the video to skip the parts that you care about. I'll be using the Sprout Lens asset pack by Cup Nooble, link is in the description. So here's how the game stands so far. We have a character that can walk around, and when we click, she attacks in front of her. We also have this cow that can take damage and eventually die. The damage is handled like so. The weapon checks if the body it hits has a damage function, and if it does, it calls it, passing in its attack damage value. And inside of the enemy, we have, and if it does, it calls it, passing in its attack damage value. And inside of the enemy, we have the damage function. We subtract the damage from the health, and if it hits 0, it deletes itself. Now I want the ability to subtract the damage from the health, and if it hits 0, it deletes itself. Now I want the ability to not subtract the damage from the health, and if it hits 0, it deletes itself. Now I want the ability to knock the cow back whenever we hit it, which we can go about in a few different ways. We'll start with the straightforward approach, and then go over some problems it may cause and a better way to do it later. First off, inside of the weapon, I'll add a new variable called knockback force, and we'll pass that into the damage.
I like this. A relevant example code do not view. Okay, I'm viewing it. Got him.
Function. We also need to know where the attack comes from, so we'll also pass in the position of the attack. Then, inside of the enemy script, I'll modify the damage function to take in these new parameters, and just apply a velocity change in the opposite direction of the attack. If I go back into the game, all seems perfect. Then, inside of the enemy script,
Yeah, this is really annoying me far more than it probably should be.
I'll modify the damage function to take in these new parameters, and just apply a velocity change in the opposite direction of the attack. If I go back into the game, all seems perfect. A velocity change in the opposite direction of the attack. If I go back into the game, all seems perfect. So where's the problem? Well, there's something I didn't mention. We actually also have these trees and crates around the world that we can also break. And since we modified the damage function, if I try to hit them, the game crashes. That's because we haven't changed the tree and crate functions to take in these new parameters. To fix this, we'll have to go into the functions and add the new parameters to both the tree and the crate. Unfortunately, even though we have to add these parameters, the tree and the crate don't actually care about them. But because we changed what we're passing in here in the weapon, the tree and the crate don't actually care about the tree and the crate. Unfortunately, even though we have to add to the functions, we haven't changed the tree and parameters to both the tree and the crate. Unfortunately, even though we have to add these parameters, the tree and the crate don't actually care about them. But because we changed what we're passing in here in the weapon, these have to have these parameters, otherwise.
Oh, nice. I think the feedback loop fixed actually.
We get a crash. I will say, if you have a small project and you're
No, it didn't. It didn't. Great.
unlikely to change the damage function, this can be perfectly fine. But let's imagine you had 20 different scripts, all who do different things with the damage function. This can lead to a lot of complexity and issues down the line, and it can just be annoying to change these functions. So what can we do better? Let's start by adding a new script. I'll just call mine attack.gd, and I'll start with class name attack. What this class name does is it allows any script in the project to reference this attack class. We'll get into that more later, but for now I'll just add 3 variables. These are attack damage, knockback force, and attack position. We can also assign these a default value if we want, but I'll just keep mine blank. That's actually all we need for this file, so I'll go back to the enemy script, and instead of passing in these 3 parameters, that's actually all we need for position. We can also assign these a default value if we want, but I'll just keep mine blank. That's actually all we need for this file, so I'll go back to the enemy script, and instead of passing in these 3 parameters, I'll instead pass in one attack object, which I will annotate with type attack. Annotating it as attack gives us 2 benefits. This allows us to use autocomplete, and if we try to pass anything that isn't an attack into this function, the game will throw an error. And so we're guaranteed that the only thing passed into this function will be an attack. Of course, right now the function has errors, so instead of referencing the old variable names, I'll instead call attack.attack damage, attack.attack position, and attack.knockback force. Going back to our weapon class, we have to change how we call the damage function. Rather than passing in the 3 parameters, we'll first start by making a new attack object and assign the attack damage, knockback force, and position like so. And then instead of passing in the 3 variables, we'll instead pass in just the attack object. I'll make a sim instead of passing in the 3 variables.
Okay.
We'll instead pass in just the attack object. I'll make a similar change to the tree and crate, and if we go into the game, we can see that everything is still working fine. There's no crash to be seen. And you can see inside of the crate there's no reference to knockback at all. That's because this object doesn't want anything to do with the knockback variables, and so we don't need to specify them here. However, you can see if we call attack dot, gamedev will autocomplete and suggest the attack damage, position, or knockback force. This means that we can add an arbitrary number of values to this class, and we have to change nothing at all in any of the functions that reference it. But if we wanted to, these variables would show up in autocomplete. To really drive home how easy it is to add something new, I'm going to add something called stun time. This won't actually do anything in the project, but we'll pretend that the enemy uses it. So inside the enemy, I'll add a new current stun time variable and assign it based on the attack stun time. And then inside the weapon, we'll account for the stun time variable
I feel like you don't need to use velocity for knockback. Why wouldn't you just say it moves like a certain position, you know? Yeah, whatever.
and assign it based on the attack stun time. And then inside the weapon, we'll account for this by adding a stun time. We'll pretend that the enemy uses it. And then inside the weapon, a new current stun time variable and assign it based on the attack stun time. And then inside the weapon, we'll account for this by adding a stun time. Once again in game, we can see that we can hit the and inside the weapon, we'll account for this by adding a stun time. Once again in game, we can see that we can hit the cow, the tree, or the crate, and everything works fine. We didn't even have to touch the tree or the crate because they don't care about a stun time, since stun time isn't relevant to them. Classes can also contain custom functions like this one that can reference the values stored inside of a class instance. These will also show up in autocomplete, and if I call the function when the enemy gets hit, we can see that the function gets called. Hopefully this shows you how useful classes can be if used correctly.
Wow. Insane. Uh, I guess? Sure. Basically, a class is just there to store variables. Is that what I'm getting at? A class is just a collection of variables. That's what I'm getting from this. Poggers. Oh, actually,
Did you know that Godot has the ability
nope, 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 nope. There you go. Time for another year-long break. Hmm. All right, you know what? Yeah, sure. Yeah, I guess. I guess I can use this. I guess I'll use composition instead of inheritance. Sure. In what situation would I use inheritance though? I feel like everyone is using composition nowadays. Yeah, okay. I don't think there's anything else I wanted to do in my project here. Except for maybe make a whatchamacallit? Yeah, except for maybe make it so that you lose the game and the ball goes out of the screen. Um, and maybe fixing this edge case here where the ball gets stuck in the wall somehow. I mean, I don't really get how that happens, but I guess so. Wait, what? Oh, I see. Yeah, so I will do that probably next time. What in the world? Okay. Uh, yep, that should have been episode 41. And you will all see me on Tuesday. Thank you for watching. Thank you for watching.